now look at graphs of periodic functions, and so far we've encountered the basic shapes, and we'll mostly work with sine and cos. So we should be very, very familiar with aspects and characteristics of the sine graph and the cos graph. Let's just have a look at the sine graph. We know that it oscillates between +1 and -1. So we're looking now at y equals sine x. Just about all the work we do, the angles will be in radians, and we know that one complete cycle fits in 2 pi or 360 degrees when we're working in degrees. So we've got to get a complete cycle from there to there, 2 pi, so this must be just equal to pi. So you halve that, and it's got to be split basically into 4. So we've got 2 pi, half of that is pi, half of this will be pi on 2. And halfway between there and there is 3 pi on 2. Our graph, let's change colours here. We've got, we know the sine graph starts here. It then goes up to +1, back to 0, down to -1, and back up there. So we get a complete cycle in there. Now that's one cycle. It continues on in both directions. So this will be what we call one period. If we wanted to look at y equals negative sine x, what happens when we change the coefficient there, which is +1 to -1? All it does is reflects this in the x-axis. So y equals minus sine x. The reflection would put that point down to there, up to there, up to there, and back to there. So and so on, continues off. So y equals minus sine x in red, and y equals positive sine x actually is in blue there. So that's what the effect of putting that negative in front of the sine does. Still has the same period, it still repeats itself over the same amount of time. Let's look now at the cos. So once again, it oscillates between -1 and +1. And it'll have a period once again of 2 pi. So it's a good idea when you're working these out to always sort of measure it out and then split it into 4 equal parts here, because it makes it much easier to draw, and it oscillate. These points are key points, so halfway there is pi on 2, and if you go back to your unit circle as you go around, this is like going straight up on the y, this is out on the -1 on the x, and then down to -1 on the y. So that's 3 pi on 2. And the cos graph actually starts up here, not at the origin as in the sine. So the cos graph starts up there, goes through there, down to the bottom, back up there, and then up there. So we've got a graph that looks a bit like that. So, and once again it continues on. So that's y equals cos x. And if I put a negative inside, it'll just flip it upside down and it'll be a reflection in the x-axis. Alright, now let's just extend those ideas to the general form, because most of our functions, our periodic functions we're going to come across are not just a straight sine and cos. There'll be some numbers involved here. Now, what do the numbers do? So I like to think of it a bit like this, that the general form for sine is y equals a sine b outside of x plus c plus d. Now that's the general form of the sine. I could have substituted cos in there and just still have the same a, b, c and d. What do a, b, c and d do to the basic sine graph? So a is the amplitude, and the amplitude is defined as half the distance from a peak to a trough. And if we go back to just say the cos graph here I have a peak, so that's my peak. Here is my trough, is the bottom. Half that distance is 1. So y equals cos has an amplitude of 1. We've already encountered the fact that if we have a negative amplitude, it means it's flipped in the reflection in the x-axis. So a is the amplitude. 2 pi over b is the period. Now the period is regarded as how far we go before we start repeating the same graph again. So the period for the cos graph here was 2 pi. So there is my period. Because once we get to 2 pi, we could pick this point up and put it there, and the graph would repeat itself again, and same going in that direction. So 2 pi on b is the period. B is sometimes given a special name of frequency. So these are key words. Amplitude is a key word. Frequency is a key word. And period has a special meaning as well when we talk about periodic functions. So we've talked about the A, the B. This has to be just x by itself. C is the horizontal shift. And it turns out that if C happens to be a negative value, then you shift to the right. And if C happened to be a positive value, then you will shift to the left. So C is a horizontal shift. So in other words, we would pick this whole graph up and move it so many units, C units, either to the left or right, depending on whether this was positive or negative. So that's the horizontal shift. And finally, D equals the vertical shift. And the vertical shift just moves the graph up and down. So let's get that back there again. So if I had +1, if you consider this to be the equilibrium line, if you had cos of x plus a 1, well, it would move that cos graph up 1 unit, and that would be your equilibrium line. Then you would do your cos graph on either side of 1. Now we're going to go through some examples here, and that will make all of this here a little bit clearer, I hope. But if we remember this as, if you like, the general form of all sine, cos graphs. Now tan we don't tend to work on so much, we'll just concentrate on the sine and cos ones. If we understand this, then as we work through some examples now, we'll know, we'll see that what happens to those numbers and how they're put into action to show what happens to the original sine and cos graphs.